Okay, so doing a little more work on this custom rear axle housing. So I got the tacks cut. This thing will take them back apart. I found a spare third member to use as mock-up, and it's gonna be part of the jig, I guess, to center it up. There'll be aluminum, like hockey pucks made that fit in here, and then it'll be drilled for like a precise shaft to go all the way through. And then there'll be 2 more pucks in each tube on either side to line everything up with a common center line, which everything needs to be based on this center line of these bearings. So I cut it all back apart. When I plasma cut this out, I left the ID of this a little tight. That way you can't count on the plasma to be perfect. So you make it a tiny bit small, and then I used a drum sander and opened it up slowly until the third member just has a nice tight slip fit in. And then I drilled all these out to the chop drill size for, I believe they're M10 by 1.5s. Anyway, so now I'm going to tap all these holes, and it gives me a reason to bring out one of my favorite tools. This little, not sure what you call this, tapping machine. It's got little arbors, and it hold the taps, and it's cool because it keeps the tap completely perpendicular to your work. So basically, you stick this guy in there like that, clamp it down or whatever it takes, and then I've used this in the videos for redoing the hub bolts in the front hubs, but it's got a nice long handle. It's got a good feel, and being that this is just held straight, it doesn't get cocked and bind, and the chances of breaking taps using this thing is really slim. I've tapped hundreds of holes with this thing and haven't broken a single tap. That's what I'm gonna do now. I'm gonna tap these all out, and then what I'll end up doing is when the housing is complete, I will get some high quality bolts, and you reach in the inside and thread them from the inside out, so there'll be like studs sticking out for the third member to slide onto. Like in a Samurai, they just give you threaded holes and use bolts. That's kind of a pain in the butt to hold the third member in there and get it clocked right. I like studs a lot better. And then, if anything were to get weird with the nut or whatever, you could change that stud out and not really be using the threaded holes in this too often. I'll have to use a good like thread sealant so 90 weight doesn't leak through the threaded hole. But so that's what I'm doing now. I'm gonna tap these all out and then bolt this in there, and then I got to get some dimensions together, and I'm going to start working on the pucks to go into this guy. I've got material, I just got to turn it down, and I don't have anything for a rod yet. I'm not sure what I'm going to use. I want to go large a diameter as possible so it's stiff. So I've got to look at all the other parts. Initially what I want to do is, hold the tubes in alignment, but at the very end, when I put the full floater snouts on, those also need to be lined up to the center bar. So I've got to take a whole bunch of notes and measurements of everything and make sure when I start building this stuff, it'll work for everything. If I got too big of a rod, then the spindle snout might not slip over it, and then I wouldn't be able to use that to center it. So I got to dig that stuff out and figure out what it's going to take. In the last video, I talked about changing this up to where I would have one weld seam here and one here. The more I mess with this, the more I like this approach better. Because this only has, in the press brake, with this all flat, I bent this bend, and then this bend, and then these bends. And it's accurate. I feel like if I made a center band and then 2 cones, or like half cones, getting these bends to where these surfaces flow together perfectly would be a lot more difficult. I mean, not impossible or anything, but I just feel like this is better. And then also for alignment purposes, these ends are pretty flexible. So if this needs to move around a little bit to get the alignment perfect with the tube, I think that's a better way of going. So I'm going to build this one first, and see how it works out. Kind of my rough plan is to build the rear first, because that's the one I really have a need for right now. And then eventually I'll build a front. But you know, in doing this a couple times, I'm sure I'll learn changes along the way. I'll figure changes out along the way. And I'm thinking about I keep talking about like building samurai parts. I'm thinking more and more about just setting up a deal where you can just buy the files, because CNC plasma cutters are kind of dime a dozen these days. They're all over the place. And so you could buy the files and have anybody cut it out, or, you know, there's all the online laser cutting places. Send Cut Send is a popular one, and things like that. So if you guys are interested in any of this stuff I make, let me know, and maybe I'll consider just selling the files instead of making the parts. Or I could do it both ways too, but let me know. So I'm gonna get to work on tapping these holes, and then I'll come back and show you when it's all done. Okay, I got all the holes tapped. I got just 4 bolts in this right now, but getting this mocked up. I cut out these bulkhead pieces. These are gonna go basically right in here, and they will weld to the inside of the shell. And basically be the second point for the tubing. One end to weld out here, and then the other end of the tubing will weld into this. And then this will also I don't know what you call it, be like a baffle inside for the oil. I'm going to end up cutting a notch, probably about a 1/2 inch wide by 1/2, 3/4 deep, top and bottom, because I want the oil level, you know, wherever that ends up. I don't want it just to be in this narrow spot. I want it to be able to get on either side of this. And then when I do the differential vent, it'll be outside this bulkhead. It'll be out here somewhere. And so this will kind of help prevent oil from wanting to get pumped out of that breather. So I've got these measured. This is 100,000ths of an inch thick at its smallest point. And just based on all the dimensions and the math, that's where, you know, this tubing should end up based on the center line. So I'm going to keep that just as it is, and then once I get my pucks made up, we'll see how well that actually works out. You can see this will be somewhere in here, just inboard of these bolts, so it'll help stiffen that faceplate and support the tubing. You know, I want this as far this way as possible, to get more of a purchase or a grab on this tubing. And then it, two purposes, a wider grab on this, and then also stiffening the faceplate right next to the bolts. So you can see the case and this are basically flush. The case actually sticks up a little, but the shell will stick up on top of that. But the faceplate will be supported very close to the bolts, top and bottom, which is where the most stress is going to be from torque reaction. And then, like I said, these guys will grab the sides and stiffen that up. So I'm liking how this is looking. I'm working on some drawings for a fixture for this too. Like I said, have a big heavy wall piece of rectangle tube that's going to be like a base plate, and there'll be clamps. They'll grab both ends of each tube. But I won't I'll set that up, I think, with this straight piece of tube. I haven't fully decided. I gotta think this through, but I think if I build the fixture to hold the tubes in alignment perfectly straight with each other, and then let the bar inside basically set the center chunk in space around it, I think that's what I'm gonna do. Like I said, this is the first housing I've built 100% from scratch. I've done like drag race stuff where you take universal housings and you cut them down, you put the bearing caps on the end and all the 4 link parts and all that. But this is the first time I've done a complete from scratch setup. So I work on it a little bit and then sit and think, let the ideas marinate for a couple weeks and then come back to it. But I think I'm gonna get the shell tacked back on, and maybe even just lightly tack these bulkheads in place and just kind of see how things look. Okay, here's a little bit of a better look what these bulkheads will look like. You can see they're real close for support to the mounting flange. All right, then this is with the shell sitting on it. And then looking inside, you can see how that bulkhead will attach to all these surfaces. And then there's separate pieces that go here. And these had to get a bend. So there's a twist, there's a bend diagonally for it to fit. But then it gives that kind of scallop all the way around the tubing so it fits tight. All right, well, it's time to design my clamps. They're gonna go onto that fixture tube. All right, so I'm just kind of mocking stuff together to get a better look. I didn't realize these bearing races are bigger than 3-inch, so I was able to pass the whole tube through it just to kind of mock this up. But you can see that these tubes will be cut off probably about halfway through this bulkhead, so that way they could be a nice weld put around it and still be physically supported. That's basically what it's going to look like. Obviously that center piece of tubing won't be there. Let me set the shell back on top, see how it fits. All right, this is looking pretty sweet. I mean, obviously none of this is perfectly centered yet with the diff, but it's really close. Like I was saying, with these kind of long fingers, it gives these flexibility to be able to move around a little bit. You can see the fit. There's no gaps once that's pushed tight. Because that's a big thing. If you have a gap and then you put a good hot weld in there, when that bead shrinks, there's no metal, you know, to help to stop it. I mean, it's gonna pull no matter what a little bit, but if you have gaps, it's gonna pull more. So I want all this to be super tight. So far, everything's fitting good. I mean, it's not perfectly aligned yet, but pretty sweet. Well, I've got to get, I had some material to make the pucks. They'll work for the tubing because it's 3-inch diameter, but like I said, I just realized that they're 3.150 is the OD on the bearing races, so I've got to get some like 3 1/4 material or whatever. But that's the next step now. I think I've got all the pieces basically as good as they can be until I have that guide rod. Really liking the shape of it. Okay, well, enough staring at this. I need to get something done. Okay, so I'm looking at the spindle snouts. This hole is 1.155 or so. So, you know, the centering bar that's going to go through, if I wanted to run through this, it'd be pretty small. So 1.150, so 1 1/8 inches, and then that would leave no room for an adapter. So like 1 inch, and I don't trust 1 inch to align all this. I just don't think that would be stiff enough. So what I think I'll probably do is I have to have a cup machined for these to bolt to. And then I guess just there'll be a puck in that cup. Where this goes, maybe I would machine a puck with a flange so it could actually bolt to the cup. It's probably what I'm gonna have to do. So it'd be a puck with this diameter of this little pilot, you know, plus whatever depth I have in that cup. And then it would have a flange, and then somewhere either just extra thickness out the back or in the center. I want some thickness this direction and axial direction to that puck, so that puck is stable on the centering rod, can't rock. So I think that's what I'm gonna do. And then that gives me room to go with like, you know, like a 2-inch or a large diameter rod to go through there. Because you know, even this 3-inch tubing, if you put it on ends and you put 100 pounds in the middle with a dial indicator, you're gonna get a couple thousandths of movement. Everything moves. But if you did that same thing with a piece of 1 inch, it would be dramatically more movement with the same amount of force. So the bigger the better for stiffness. So it's gonna be a lot of machining. I've been kicking around the idea of 3D printed adapters and pucks. I've got access to a printer and I might try that. You know, just make some up and then measure them and see how accurate they are. But we'll see. Just holding this guy up here, I like this. This is gonna be nice. Like I talked about before, one of the benefits is if you break an axle, the axle fits through this hole, and all you would have to do is pull your locking hub off and pull that broken axle out and slide in a new one. And like I said, when I work with RCV, whoever makes the axles, I might have them make it to where it's got just the most minuscule, smaller section on the outside, so that it doesn't want to break in the splines in the inside. It would be more likely to break out here, because usually when they break in there, they expand and they get stuck in the spider gears or the spool or whatever you have, and it makes them really hard to get out. I've had them break and I just had to pull the whole third member, pull the whole axle down, and actually pull the carrier and everything out in order to hammer that broken piece out. So I want to avoid that as much as possible. So, you know, out here, the outer splines, you know, maybe just inboard the splines, have them put a tiny dip or, you know, whatever. You know, they know that stuff more than I do. That's something I definitely will bring up to them when I have these made. And then, you know, this big 4-bolt pattern, the disc brake mounts will come off of that. And I'm hoping to lubricate the bearings just with the 90 weight, because the fill level will be full enough, you know, anytime you articulate or go around corners, the oil's going to move one way or the other. Because otherwise, there will have to be like a sleeve on the axle shaft, and then this cup would have to be necked down and use like ones I've seen before used a rear axle seal, and then they machined a piece with a set screw and silicone like it for a hook to the axle shaft, and then you couldn't just pull the shaft out without removing this. I don't like any of that. Basically any of your 1-ton trucks with full floating hubs, the 90 weight lubricates the bearings, and I think that's a better system anyway. I'm just not 100% sure about the sealing. I mean, I don't know that there's any kind of a difference between a grease seal and oil seal. I'm gonna have to research that. But there'll be this seal, and then the base of the locking hub will have to be sealed well, and then also the cap. None of that stuff was made to run 90 weight, but it was made to keep water out, so I imagine it'll work. All right, well, that's where I'm going to end up for today. Okay, so here's kind of a start of my fixture. So I got this piece of tubing. It's not as big as I first thought it was. I have store a lot of steel in a different spot, and it's been a while since I saw this. I thought it was 4x6. It's 3x5, and it's quarter wall, but I still think that's going to be fine. So the plan is to drill and tap this and build plates that bolt on, and then plates that'll come up. I was going to build my own clamps, and then it finally hit me like you can buy these cheap. So I got 3-inch muffle clamps, and I'll probably make my brackets. I don't know, I haven't figured that out, but I want to reinforce these so they're strong. But I think I want to build this to where this is kind of the height I want this, so that the housing is off, and I could loosen these and rotate the housing for better welding positions. And probably what I'll do is, once I get one housing done and it's straight and I'm happy with it, I will build a plate to take the place of this, and then also make it a stand and have it bolt onto this, so that when I go to build a new one, I can bolt this faceplate into position and know it's in the right spot and not have to use a third member every time. Although that might be a dumb idea, I don't know. My gut feeling is, like, if you build a good enough jig, I don't think you need an internal bar every time, but that's probably a dumb thing to do. I put some thought into these end caps, or these, what would traditionally be like a bearing cup. I was going to make them slide over the tubing, but then I realized that's pretty dumb, because if any, wind distortion happens in welding this up, this could move relative to the bearing center line. And if your end piece just butts to the tubing, then the tubing can be a little off center, and your central bar will hold the cup in place. That's why I say I think I could basically build a housing without a center bar once I have this fixture built, but then the center bar will just be needed at the last step to put the end caps on. And ideally, you want to do that, if there's going to be additional trussing and the link mounts and everything that would be welded on these tubes should be done first before the end caps. That way, any distortion that happens anywhere in this tubes, the end caps will be put on last and centered with the internal bar off of the bearing center line. So even if this thing gets, an 1/8 of an inch bow to it or whatever, it really doesn't matter. So now I'm trying to, I was talking to a friend last night, and we were looking at this thing and going over it, trying to get a good order of operations set up and figured out ahead of time, kind of dry run it a couple times and make sure things are being put together in the right sequence, so that I'm not, like painting myself into a corner to where I can't get weld in the spot because it's now closed off or inaccessible. So what I've seen other people do is basically get the shell, this and the faceplate done as a unit, and then, and sometimes that takes its own jig, and then do the tubes to it in a jig. But still, even just the steps involved in putting this together, I've got to figure out. I just thought of right now, I think I might go into the computer, and I have these, I know the position of these in the computer in this direction. So I might build a fixture, just like a simple plate that would bolt to this plate and be a surface for these to come against, to be square this way and the right distance this way. And then I could easily add to it for squareness this way. Because getting these welded first would probably be best, because once this is all enclosed, to get inside, it would be pretty difficult. Not impossible, but just trying to make sure I have good solid welds inside. I mean, luckily, the being watertight or, not leaking oil, that's really just all the welds on the outside. Like I said, my plan right now is to let oil basically be in here and out in these outer little chambers, just for extra capacity. But still, trying to think that through. One thing I like about this design, and I don't remember if I mentioned it, I know at one point I talked about making a shell and a shell and a shell, or like a half cone, and the center piece. But I like this design better now, the more I mess with this. And originally I was thinking of getting these, as part of that plate, and then this would just be a bend. But I like this being separate because it leaves a window for welding, getting into these bulkheads and in places that would be, hard to see. And even if, the welding gun comes up through the main hole, well, having this open so I could see, or whatever. So I think this design is going to stay. Because these, this is all just outside welds to put this on, other than getting inside and welding to this bulkhead, which should be easy. So I think by accident, I came up with the right design. it's a super easy weld. I'm gonna get these 4 stands. They're kind of like an adapter between the clamp and the base tube, and then a bolt-in plate. I don't, because I want to, just to explain that, I don't want to weld to this at all, because I want this to stay straight and true as possible. And so I want to do just square, probably like 1/4 inch thick square plates with 4 bolts, and then that'll come up to this. And same thing out here, and then 2 over there. For a couple of reasons. Then I can keep this nice heavy tube as kind of a universal fixture, you know, because if I do a front housing, these are all going to have to be in different spots. These inner ones I imagine could stay, but these outers would be different, just because the way you fixture up a front is a little bit different. And I'll post up a picture of my front I built. I have a picture of it on a quick jig I built. But basically, I assembled everything. I had the knuckleball slid in, and the steering knuckle was on and adjusted with the kingpins set up where it was going to be. And then I built a plate that came up and bolted to the face of the steering knuckle. And that way, that gave me a true surface for square for 0 degrees camber. And it just held everything straight, and it seemed to do a pretty good job. So it's pretty true, and a lot of this stuff is like, sometimes you don't know how to build it until you first build it wrong. You know, got to learn from your mistakes and move forward. So I think that's it for now. I'm not sure if I'm going to wrap up the video here or if I'm going to keep going on this one, but we'll see. All right, I'm going to go work on these drawings. Here's a couple quick things I thought I'd share. So this is basically the pattern of the flange for the spindle snout. And this was my original plan, was to have a thick piece machined out that would slide over the tubing. You know, this is the axle tubing. But now I'm just going to do a plate, like I said. So now this will just butt up to the end of the tubing, and that way it's got a little bit of freedom for misalignment. This would, you know, the tubes would have to be perfect for this to work. I know this would be stronger, but this, you know, with a good weld, you know, a 3-inch tube has got over 12 inches of circumference. So 12 inches of weld, if that were to break, you're probably already dead, whatever impact that was. Then the other thing, this is those bulkheads. And so I just added these little half circles here. So I did it top and bottom so that it's universal, left or right, inside, outside, it doesn't matter. And then, you know, however it sits in the case, these lower 2 would be so oil can move between basically the 3 chambers, and then the upper would be for air because the venting. So this is the bulkhead right here, and the same thing on this side. So that way, you know, because the oil level is about 1/3, roughly speaking, the way up the case. And so that way you'd gain all this area over here for additional oil. And then when I do the vent, I'm going to do it off to one of these sides and one of these outer chambers. And then, you know, for a couple of reasons, clearance, you know, in the front housing is a clearance issue. And then second thing is, I've never run into this issue with this because I've been careful about it, but I have seen where if you accidentally put the vent above the ring gear, if you're going fast and really moving a lot of oil, it can basically pump your gear oil up and out of your vent. So you always want to make sure your vent is a ways off axis, or, you know, off that plane of where the ring gear is. So I want to put it in one of these outer chambers, that way I know it'll be safe. And And that's that on that subject. I'm getting ready to draw those clamp stands. So while I had the image up, I just remembered I wanted to make this change, and then that changed, so I figured I'd share that. I'll come back when I've got these adapter plates and stand pieces drawn up. Okay, so I bought these muffler clamps. I've decided not to use this piece. It's just too flimsy and it really doesn't fit. I mean, these were labeled 3-inch, but I imagine what they're made for is to, it's really like 3 1/8, because you got the pipe gets belled out and this has got to fit over that. So I'm not going to use them, but I will use the U-bolts. And so this is the rectangle tube for my fixture. This will be like a side plate, you know, so that's the tubing, the axle tubing. And I decided, instead of a circle like these, to do 2 45-degree straights, because that's a lot more positive in location and it's a lot less, you know, precision. To get the tube to be positively held in place with a semicircle, it has to be perfect, because if the tubing's a little big, it'll hit these corners, and if this is cut a little too big, the tubing will just sit in the bottom here and have space on either side. So I got two lines with, you know, 90 degrees between them, and then this will be the new plate that the U-bolt goes through, and it'll go across there. So I'm going to cut this slot for these tabs to go through, to kind of be like a key junction. And then also it would be hard to weld inside, so it's going to be 2 plates. So this is looking from the side and this is looking at it, you know, turn 90 degrees. So that's the U-bolt plate, and this is 1.5 inches between them, and then this is 4 inches, and so it'd be hard to get in there to weld. And with these little tabs, they're actually going to stick out proud of those plates 1/4 inch, so I'll have plenty of room to weld. And then this will be the base plate that'll bolt to the tube, and I drew these on a 3x3, the center lines. That way, it's kind of a common, I mean, not common, but I mean, it's a good number, so I could kind of draw a 3x3 grid of threaded holes on that tube if I were to use it for other fixturing. I was trying to go 2x2 or a 4x4, because that's what my welding table uses, but it just wouldn't work out with that tubing. So that puts the base plate, you know, kind of fills up the flat of the tubing, and then gives it plenty of room for the bolts. And then I'll bolt those down with like 3/8 bolts. This U-bolt is 3/8, or I imagine it's 3/8. Maybe it's not metric. I have no idea. But that way the tubes will be held, you know, in space, solid. And what I'll do is I'll put these together, and I won't weld the base plate on. And so I'll get these, you know, the 2 side plates and the U-bolt plate welded together, and then I'll put all of them together along the tubing where I want them to be, and then I'll set the tube down, you know, after I bolt. I'll drill and tap and bolt these guys, you know, so if there's any variance in these side plates, you know, they're gonna be made on the CNC, but it's not perfect. You know, plasma varies from cut to cut a couple thousandths, just from how the flame dances around. So I'll attach these guys all to the tubes, attach the plates all to the rectangle tube, and then, you know, if there's any gaps or whatever, I'll see them, and I could hit them with the sander, or just, you know, if it's minor enough, just weld them up. That way everything will be set. These position of all these will be set by the tubing, and that way it should be, you know, as perfect as I can make it. From how I have it mocked up out on the welding table, this is a lot shorter. After thinking about it, there's really no need to have the third member in the axle pointing straight down. If I need that in there, it could be either pointing up or sideways or down into 45. But that way that shortened these positioner stands up considerably, which will make them stronger. You know, less flex, less give. So I think that's my best deal. Like I said, I'm going to make 4 of these, so there'll be 2 on each piece of tubing on each side. That way those tubes are, you know, held in space, you know, in every dimension. And, you know, I'm going to set these all up with one continuous piece of tubing, you know, and before I do that, I'll put straight edges on the tubing, make sure it's doesn't have any flaws or bends or bows in it. That way I'm starting with something straight, and then when I cut my individual tubes, you know, those stands they're set. So I think that's the deal. I think that's the process. And then I will make up the pucks, and I should be pretty set. After drawing those new plates that are going to adapt the spindle snouts to the tubing, I'm pretty sure I can get away with a large diameter, like a 2-inch diameter center bar, you know, alignment bar. You know, because I think the bigger the better, so it doesn't flex. You know, it's amazing how much steel flexes just from, you know, its own weight, or, you know, if anything acts upon it, it flexes. So the bigger the better. So I think that's it until I get these cut. Like I said, I believe once I get the first axle built and I test it for its, you know, for bringing true, then eventually I'll build another stand that will bolt to this rectangle tube, but it will be to go up and to hold the faceplate where the differential mounts. That way I could reproduce housings without needing any factory parts. Except, well, yeah, and I still would need, no, I take that back. I'm always going to need a differential, because to put the end caps on, you're always going to want to base that off the differential. Unless I could have somebody machine me something that would be a stand-in. But so I guess I'm on the hunt for another third member, because this one I just picked up is going to be built up as a spare when I'm done with this. So if anybody has and it can just be an empty case, I just need the case, the 4 bolts, and the 2 carrier caps. So if anybody has one they want to sell, let me know. Okay, so it turns out I don't have enough material to cut out all these stands right now. So I'm going to go ahead and wrap this video up right here. Once I get the material and get those made and some more good progress, I will pick this up on another video. So thanks for watching. You know, if you like this stuff, it'd be nice, give me a like and a subscribe. It helps get these videos out to more people, and I appreciate you watching. Thanks.